Hi, how's it going? Welcome back to Mr. Haas's math help videos. This is lesson 11, part 2. So it's going to cover another thing that we haven't worked on much before. This is called LCM, or least common multiple. Not to be confused with GCF, that's something else. It's actually the reverse of it. Because in GCF, we were looking for the smaller parts of numbers. Here we're going to take those numbers and make them go bigger. Multiples are those numbers we get by multiplying a number times, like 1, and then multiplying it by 2, and multiplying it by 3, and so on. Okay, so this is what that looks like. So what we've got, let's take a couple of numbers here. Let's take and see least common multiple of two numbers like 9 and 4. Okay, well, 9 times 1 is 9. And what we're going to do is we want to find the common number on both of these lines, and the least meaning the smallest one. Easiest one would be to multiply these two together, but it's not always the case. Sometimes you can find one shorter. Okay, so back to where I was headed. 1 times 9 is 9. 2 times 9 is 18. 3 times 9 is 27. 3 times 9 is 36. 4 times 9 is 36. 5 times 9 is 45. I'm going to stop there because this is getting pretty darn big. 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. 4 times 4 is 16. 5 times 4 is 20. 6 times 4 is 24. 7 times 4 is 28. Do you see any on the same line here? Nope, not yet. 8 times 4 is 32. 9 times 4 is 36. There we go. Got one. All right, so this is the smallest or least common on both multiples. So I have 1, 2, 3, 4 times these numbers. So that would be the least common multiple for each of these. Okay? All right, well, let's try and see how it goes in a problem. So what we've got is, let's say that we have a certain number of something, and we want to find out, okay, how many of these does it take for them to equal each other? So here's a situation. We've got two students, and they are jogging, and they're just jogging around this track, and they do it during a week, so over several days. And student A takes 10 minutes of jogging each time they go out. And student B goes out and jogs for 16 minutes. Now, the question is, when will they match up? When will they have jogged the same amount of time again? Because, each day they're going to each jog the same amount. So let's look at the multiples for student A. So they're going to go 10, 20, 30, 40, 50, 60, 70, 80. I'm going to stop there because I'm running out of paper. So then student B goes 16, 32, 48, 60. Oh, I'm sorry. I jumped ahead of myself. 64. Is that right? 80. Hey, I got one. 80. So at 80 minutes out, they're going to finally equal each other again. Notice it took a lot fewer times for person B than it did for person A. But that's when they would match up again, is when they both had done 80 minutes of jogging. Okay? All right. Well, thanks for watching. Hope that helps. See you in class.